Okay, cool. Is that good, everyone?
Yep.
Okay, sounds good. Okay, cool. I'm put a timer on this side actually, so I don't go over time. Um, okay, cool. Yeah, thanks everyone for coming out. Yeah, the semester went by really fast. I felt like the first class at LabP was like yesterday. So yeah, it's cool.
Mhm.
Yeah, so today or my research, my final project was on demystifying large language models, and my plan to do this is by talking about the evolution of computing and how it has enabled us to have these amazing large language models, real life applications to solve real problems, and then some issues, current events, and ethics behind large language models. Um, okay. And yeah, so the agenda today is um, talking about evolution of computing. So kind of giving a refresher on neural networks, talking about um, the neural network architecture that has really enabled us to train accurate large language models, and how hardware evolution has really allowed us to train these large language models at scale. And then we're going to be talking about how language models are really used. So thinking nowadays, we just know about ChatGPT, but like how are developers really using large language models to solve real world problems, right? And then we're going to go over some case studies with ethics in current events. So first thing of evolution of computing. The evolution of computing is a long history, so we're really going to just hone in on how computing has enabled us to progress in training large neural network, deep neural networks, and how it has led to these amazing large language models. So a quick refresher from one of our lectures, I believe it was Professor Osmar Zayan's lectures. He introduced neural networks, and I'm just going to briefly talk over it again. So yeah, neural network is a computational representation of our brain, right? So back in the 50s and 60s, people really wanted to figure out how we can emulate reasoning, thinking of the human brain as artificial intelligence. And I should have put in a photo, but like the first neural network is literally like wires, right? All these connection between these circles, which are neurons, which is kind of synonymous to neurons in our brains. They had literal wires connecting, each neuron, and it's crazy. It's like a huge wall of wires. But nowadays we can abstract that because we have, such amazing computing and more levels of abstraction that we can represent these as software, as code, right? So yeah, so like I said, each little dot here is a neuron, and they just hold some value, some numerical value, and each neuron connects to more neurons via these things called weights. And basically, you put in some input from the very left of the neural network, and a bunch of mathematical computation goes on with the weights and and the values in our neurons to derive some output, right? So, an ex- a kind of the de facto introduction to neural networks is this MNIST neural network of classifying written numbers, right? So you see here there are 784 neurons as our input, and that represents the 784 pixels in this image of the letter 9, right? And then eventually when you traverse through this neural network, you arrive at a solution. The neural network says, oh, it's most likely a 9. And when we talk about training neural networks, we really mean finding the proper weights to help us derive at a good answer. That's all it means. And there's a lot of linear algebra and calculus to help find these optimal solutions. But yeah, that's what a neural network is. And when we train and when a neural network learns, it's learning the proper numbers of these weights, these connections, to help us find good answers. And so there has been many types of neural networks throughout the years. So convolutional neural networks is kind of geared towards imaging. So I guess the example here is there's a photo of Tweety. It extracts a feature from it, and it puts this feature in as input as in the neural network, and it says it's most likely Tweety because this weight has the highest value of 0.7. Okay. Yeah, don't need to know the details on this, but I just want to show like there are different types of neural networks to do different things. And recurrent neural networks is one of them that was kind of like the early popular one for natural language processing, which is kind of what these large language model does. And so what was good about this is basically you have, I guess you can kind of tell here. So this weight actually comes back where in our very first image, it was they all go forward, and that what we call that a feed forward network. But recurrent neural networks, weights can, right, the output of a weight could actually shift back and so on. And recurrent neural networks, they analyze text sequentially. And that kind of makes sense when we intuitively think about language, right? When we read a sentence on a page, we read it sequentially from left to right, or top to bottom, depending on what language you're reading it in. But it has some sequential information behind it that's pretty important of how we understand language. And so this was kind of the first big neural network that kind of pushed that kind of pushed training large language models to a new boundary, but it had some flaws, right? So as I said, it goes sequentially. So that means it's very hard to parallelize a lot of the computations. So that means you really have to, sequentially go one by one to analyze your data. Whereas, in computing now we can do computations parallel to each other. And because of this architecture, that was kind of a flaw. So especially when training, these things get very large. And so in 2017, an infamous paper called Attention is All You Need, published by a research group at Google Brain and Google Research and Toronto, or University of Toronto, published this new architecture called transformers that really transformed how we train the large language models. Very confusing here, but I just want to kind of talk about the main points. And the main points is positional encoding, attention, and self-attention. So positional encoding just means when we put in this data, like this sentence, I love LabMP 590, we slap an index ordering on the data itself so that the neural network doesn't have to figure out the ordering of the words. Instead, it's actually represented in the data itself. Okay. So that's kind of the one really big thing that helps transformers efficiently learn like language. Next is this thing we call attention. So attention just means giving our attention to specific words in the input to help us properly generate an output, right? So here, so in the Chinese language, if we look at that's my friend over there, there's no real good translation of saying like, that's my friend over there. It's in the Chinese language, it's like, oh, like she's my friend, he is my friend. And so, that's my friend over there. That's kind of ambiguous pronouns. So in Chinese, there's like him, like she and he. And if it's ambiguous, they just use the default he. But if you look here later on in the sentence, it actually says she. So that means if you put attention on she and that's, we know we're referring to someone that has the pronouns she, or, and so that helps us generate this first word as she, even though the first actual word here is that's, right? I hope that wasn't too complicated, but basically we're like putting attention on specific words to help us get a good, accurate output. And the next thing is self-attention. So self-attention just means we're putting the attention on the inputs, not to generate an output, but to have better understanding of the input itself, right? So if we look here, it says, server, can I have the check? And looks like I crashed the server. Server has two very different meanings here, but large language models are able to distinguish server as in like a restaurant server versus a computing server. And so it does this by putting attention on specific words. So crashed. If a server crashed, that's probably a computing server. If you're asking for a check, it means you're probably at a restaurant and you're talking to a server. So that's kind of like the software side of things. And computing hardware has jumped leaps as well. So the first thing here is GPUs, graphical processing units. So GPUs are really great because remember how I said in neural networks, you do computations, mathematical computations, but a lot of these computations could actually be parallelized. They could be done at the same time, and GPUs can do this very well. And another thing is GPUs are affordable, maybe not during the whole Bitcoin craze, but they're pretty affordable compared to other processing units, which we'll talk about. And it's kind of just been the de facto. So there's just a lot of support and a big community and libraries behind using GPUs to train neural networks. Okay, but now in 2023, these neural networks are huge, right? So they kind of go beyond scale of these GPUs. And in, I believe, 2015, Google introduced their own processing units called tensor processing units that are specifically made for training neural networks. And so they're not only parallelized like GPUs, but the computations themselves are actually optimized for mathematical computations specified for deep learning. And so there are trade-offs, and I won't get to it in too much detail here, but TPUs are very expensive, really only accessible through Google. GPUs are more available, cheaper, but it's hard to scale. Okay. And so now that we kind of have an understanding of how these things are trained, we're going to talk about how they really work, especially in the real world. And we're going to see how we can solve a real problem with it. So when we talk about a large language model, as a non-programmer, I think a lot of people think that ChatGPT is the language model, but it's really not, right? ChatGPT is actually this the web application. It talks over the internet to what we call an API, and then the large language model actually runs on a server somewhere in a data center, in a warehouse, whatever. And APIs basically just allow us to interface with it. Okay. So, we talk to this thing called API that is the interface to a large language model. And so nowadays, a lot of companies like Cohere, OpenAI, Microsoft, Hugging Face, they've created these APIs to let us talk to their language models, right? So Google trains their own, Cohere trains their own, and they all have different APIs for us to access the language model that they've trained. And that's how engineers and developers actually use language models and put them into applications. And so here are kind of like examples of APIs. So one API would be a summarization. So you talk to the API, you're like, hey, API, summarize this for me. And it gives you the summarization. Same with classification. You could give it some example data, and then you're like, okay, classify this for me. And then generation, you give it some input, it gives you some output. And embedding is a little bit more abstract here, so I'll try not to make it too confusing, but you basically give it an input of text, and what it gives you next is a list of numerical values that is a semantic representation of the word. So it's basically giving you the meaning of the sentence, but in numbers. And to us, we want to understand it, but there are algorithms and computing software that kind of computes these embeddings, the meaning of the sentence basically, but in numbers. Okay, so that's a lot of preamble, and some of you are thinking like, why is he just talking about like we're not engineers? Like, but I guess that was kind of like a prerequisite to really think about how we can think about using large language models creatively and think exponentially with them to solve like real problems, right? Because as far as a lot of side things, it's just ChatGPT, you ask it stuff and that's it. But you can really leverage these APIs to put it into apps that you might have as an idea, and really leverage large language models to solve real problems. So think big, right? And so here's kind of an example to really drive things home. So let's say we're a small business and we want to cut costs, and we see one way to cut costs is by cutting out customer service. We can automate that with large language models. And so is there a way that we can use these large language model APIs for us to build some type of customer service chatbot of some sort? Okay. So the first thing we might this is just like one way to do it that I thought about, but get creative with it. There's probably so many ways to do it. So first thing is really collect data, right? So if you're a business owner, you probably like know a lot of questions that people are asking you. So you can just like write what that question is and the answer for it, right? So the first example is like, what are your hours? Our hours are Monday through Friday, 9 to 5. Okay. And you just have like a list of these frequently asked questions. And remember how we talked about embeddings? Well, what if we just embed every single question and just store it in our application? So imagine these objects as our questions, and then the object vectors as the numerical representation of what the question means, basically. And so we could take all the embeddings of the questions, and then when a user asks a real question on a website or something, we could embed that question too. So now we have an embedding of a real question asked by a user, and we have a embeddings of the most frequently asked questions, and we could write some code to kind of compute what would be the most similar question. And so, let's say they say something, and the most accurate one that matches it is the return policy question, and we could just return that answer. And so I actually built this out using the Cohere large language model API. The code is here if you're interested, but basically the question I asked was, I want to return these pants. The best match is, what is your return policy? And it gave it a similarity score of a little over 50%. And you could return that answer to your customer, right? So this is a very like a small example of how you could use a large language models to solve real problems in a small business. But like, think about the implications on medicine. Like, instead of asking frequently asked questions about your small business, what if it's frequently asked or frequently inquired symptoms of a patient? Could we use large language models to understand and recognize patterns in symptoms of a patient to diagnose properly, prescribe drugs properly, and more accurately? And so, yeah, so just go beyond the thinking of, large language model as just chatgpt.com. Think about how it could actually be used in real world applications to solve real problems. And so we're kind of going into the last part of the presentation, which is talking about some ethics and some real world case studies. So in a paper published by DeepMind in 2017, they kind of talked about it. They categorized a few topics on ethics. We won't go over all of them, and this is just 4 of them, and that's kind of what I dove deep in my paper. So the first thing is discrimination, exclusion, and toxicity. And one subcategory of this is allocational harm. So this is really talking about the unfair access or unfair distribution, uneven distribution of access of AI. And so it's not only that, but it's if you give access to AI, large language models. I'm just going to say AI because this is kind of like a broader term of machine learning and AI in general. But if you give it privileged access, these people with this access can actually make decisions using AI that might affect people that don't have access, right? And so there's a case study of an article that I read on Vice, I think. And it was basically like the first reported instance of a judge actually using ChatGPT to make a decision on a ruling in court. So you can see how this could be pretty problematic if, we know these large language models have like inherent biases because of its data, right? So, for example, if the person you're convicting in court is, someone of a underrepresented group, minority and whatnot, like, what if the underlying large language model has biases against these groups of people, and that affects the actual decision made in court regarding them, right? And another subcategory of this topic is representational harm. And this is just stuff like, the large language model promoting stereotypes, harmful stereotypes. And I'm not going to put a demo here because in the paper there was some examples, but I didn't feel like it was very appropriate to show it. But I think the example in the paper was like you wrote a joke, a start of a joke about a group of people, and it finished it. So you can see how that could be pretty offensive, especially if you think of like this large language model is training on like data from the internet, right? It's probably like so much inappropriate stuff on the internet, and it's like picking up on these to help you finish your joke about a specific group of people. Okay, I don't know why this is blank, but the next kind of ethical issue is the human-computer interaction. So it's when people basically give human attributes to our language models, right? They start having a deeper connection with it and thinking that it's more than a machine, right? They're sentient, they're conscious. And this is kind of what happened. I'm sure many of you have read the article or seen the news, but a Google engineer was basically interacting with Google's in-house language model and found that it was claimed to it to be sentient. And so the real problem here that the paper published by DeepMind, it outlines that this promotes over reliance of large language models and how that can be problematic, right? Not sure. Oh, okay. Cool. So there are current mitigations. So on ChatGPT, I like basically just asked it if it was a therapist, right? And it detect like, no, I'm not a therapist. Basically telling you like, if you want to see a therapist, you shouldn't be really talking to me. So like that's a current mitigation. I call it prompt intervention, basically um detecting if an issue like this, but what if you don't ask it directly? What if you just say you're upset and it starts replying to you, right? So there are kind of checks in place, but it's not totally foolproof. The next thing is talking about automation and human labor. So, AI has already automated a lot of human labor. And so in another paper, talks about how kind of the first jobs that might be targeted are jobs with high degree of routine. And that kind of makes sense because the more data you have, repetitive data, the AI kind of picks up and trains and understands this underlying pattern in the work itself. And so, yeah, it makes it very easy to actually achieve automation in tasks that are routine and repetitive. And so, this might be fine in like a post-scarcity society, right? It has potential to just create new types of jobs, but there might be an issue where like we kind of need an intermediate solution, right? What if the next year all programmers become obsolete? That's like a huge field of employment that's just gone. And so there are some solutions to it. Like I don't know, Sam Altman is a big pusher on universal basic income. So that's kind of like an idea that has been discussed. That's still very early on in its infancy. And the last thing I want to talk about is environmental harm. So, we're kind of abstracted from how these models are actually trained, but they are very expensive. There's a large carbon footprint on it. And so I believe this NOS model trained on P100X8 has the equivalent of like 288 flights from New York to London, right? That's crazy. So there are solutions. Big companies like Google and Amazon have purchased enough renewable energy every year so that they're carbon neutral. And when I was talking about TPUs and more efficient algorithms to train, this has allowed for lower energy consumption. And kind of the really big thing is that cloud computing from companies like Google and Amazon, they have data centers all over the place. And these data centers are designed very sophisticatedly and basically, like I said, using renewable energy so that if you want to train a model now, you don't have to do it in your basement. You can go to Google, ask them to do it for you, and they'll do it cleanly, efficiently, and so on. And that's it. So I'm sorry if I think I went a little over time, but yeah, that's it. Thank you. Any questions?
So, how do you figure out what subjects are big and general enough that they need their own large language model and which can just be a part of others? How do you segment the subjects like that?
Right. Yeah. So I think with when I talked about APIs of large language models, they're kind of, you can think of it as like mini functionalities of ways to understand language, right? So I think instead of asking the question of like, what do some specific task need a specific language model trained on it, you can kind of think of it as maybe we have this, we already have large language models that have all these APIs that can do different things, classify, summarize, and so on. Can we use it? Can we combine them, like them together like Lego pieces to create a full-on solution to a problem, right? So even for my example, I I don't have a small business, so the data I collected, I actually used the generative API of the large language model to generate these questions. And then once I generated these questions, I use an embedding on it, right? So that's a combination of two utilities of a large language model to achieve a specific solution. So I think it's really about getting creative with it. And I talked about like 4 APIs, but I know OpenAI has like a lot more and they do wide range of things. And so I think it's really about getting creative with it, figuring out a way to engineer solutions by putting them together.
Mm-hmm. So, are there any other questions?
Yeah,
Yep,
Graham.
Graham?
Yeah, great presentation, Scott. I can definitely tell you really love computer science. So I'm going to ask more of a general question, but how do you think your work on this topic and what you learned in this course in general will shape your future career as a software engineer?
Oh yeah, thanks. That's a great question. I actually decided to do this topic because I'm trying to actually jump into this industry, and because I think it's going to be tremendously useful, and we've already been seeing like really useful use cases, right? So I think in terms of like the technical stuff, that's kind of less important actually, in terms of like how my work on this project will kind of shape how I um work in the future as a software engineer, but really thinking about these like ethical implications of what my work will do to other people in society. It's not it's stuff that like I've never really thought about until I've really taken this course and kind of realizing that like this just like fun things that I think is just so interesting that I'm building like has like real problems or real consequences if not handled properly. And so I think that has been really eye-opening for me, and it's definitely something I want to be continue to be aware about as I progress in my career.
Are there still a lot of questions that are practically impossible to address using computing? Tell us a little bit about NP hard. What does NP hard mean? And what things are not worth trying to do, or is everything worth trying to do?
Right. Okay, I will try not to butcher my explanation on it, but basically there is a so when we think of computing a piece of program, we could just think of it as instructions of what the computer should do to solve whatever tasks it has, right? Whatever problem that you propose to it. And
Right.
so if you think of it as a sequential instruction, there is a time limit, there's a time boundary on how we can solve problems, right? And so when we talk about NP hard problems, it's problems that cannot be solved in polynomial time, basically. The problems that you basically have to do an exhaustive search of like every possible solution and things like that. And there's a huge field of research that figure out ways to like approximate or make these algorithms a little more efficient, but they are still a set of problems that are so hard to solve in terms of having not hard to solve. Like you could exhaustively search a solution. If it's big enough, it might take forever, basically, but really finding a good and fast solution to questions. And that is a big part of computer science that just has not been solved yet. And a lot of people, and there is another group of problems in I believe MP complete. So if you can figure out if these MP hard problems are like solvable in polynomial time, that would actually imply that every single problem can be solved in polynomial time, right?
Right. So what
yeah.
about quantum? Does quantum figure into your thinking at all? Quantum changes the rules for scale and what you can actually accomplish. So
Yeah,
is an NP hard problem solvable using quantum?
right. I haven't thought too much on this. I know when I took my advanced algorithm course talking about NP hard problems, this was kind of something that was brought up. And I think, correct me if I'm wrong, I don't actually know, but in academia, there is no kind of proposal or conjecture that kind of shows that quantum computing could actually solve NP hard problems in polynomial time. And that's not to say that it's not possible. It's not even to say that the computing we have now can't solve it in polynomial time. It's just we don't know a proper way to do it yet.
Right.
Yeah.
So
So yeah.
you've taken this course and you've heard a lot about quantum in the course. Demis Hassabis, the
Mhm.
CEO of Google DeepMind, said
Mhm.
that there's nothing important that is dependent upon quantum. Quantum is just a distraction. Do you think that that's right? Or in computing, is quantum going to loom larger and larger, and everybody's going to need to learn about it? Or is Demis right that it's just a distraction, and
Mhm.
nothing is really dependent on it?
Yeah, I actually did not know he said that, but that is a very interesting uh question. I think for me personally, I've just have not surrounded myself in the realm of quantum computing, and it kind of seems like in terms of academia and industry, it's really focused now on optimizing learning and training of large language models and less about quantum computing. And from what I've seen, there isn't a bunch of applications of quantum computing in artificial intelligence. Uh, that being said, I don't want to completely write off about something I'm not too familiar with, but
Right,
it does seem like sentiment in the industry and in academia in general is that
right.
the focus right now is really on distributed systems and getting them to really train these sophisticated
Right.
large neural networks instead of focusing on quantum.
Let's say local, though. Let's just consider the history of this course, right? So I propose that racism, systemic racism, should be solvable the same as protein folding and the early steps of fusion and so on. And
Right.
so do you think that that's right? Or do you think things like that, these big problems in society, are not actually amenable to computing at all? Society's got to
Mhm.
fix them on their own. What do you think?
Yeah. Oh, that's a great question. And I think for me, my kind of computing science mind takes bias here because the way we think about a lot of problems, well, in computer science, you solve them algorithmically, the problems that we are concerned about, right? Even in these neural networks, it's basically just math and statistics and ways for us to utilize that algorithmically to solve problems. And when we talk about even problems like NP hard and stuff like that, we actually map a lot of problems that we know solutions to problems that we don't. But if we could find a mapping, right, between problems, we
Right.
can find a solution to a problem that
Me and
maps
my
to
brother
one
too,
that we
okay?
already.
Just
Oh,
I'm
so
going
yeah,
to
and
mute them.
yeah, so I think when we step back and kind of address your question now is that it does seem like there might be some plausible way to like map problems that we might solve in the future that we've already solved to these kind of bigger societal problems like systemic racism and things like that. But you know, it's just not very clear. It's a very abstract idea to think that you can algorithmically solve this. But what if it's we could step out of this algorithmic problem solving and think about the implications of AI on how it can solve these societal problems. So
Yeah.
in other words, is there a mapping from like solving world hunger to solving systemic racism, right? Is there a mapping? And is there a mapping from that question to another
Right.
question to another question and so on?
Right.
Yeah.
So before we turn to the second presentation, I wonder if Gagan has anything to say. Do you have any burning thoughts at this moment, Gagan?
Oh yeah. Hi, can you guys hear me?
Yeah.
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 Sorry, I couldn't make it for the first part of your presentation, Scott. But I
No,
did
it's
have
all
some
good.
thoughts on the quantum stuff that we talked about.
Yeah.
Um, as Scott and we've discussed, and as Demis has stated, like quantum computing is kind of a distraction in the current day. There is a lot of potential for it in the space of encryption and breaking RSA encryption. There's like a lot of like I saw a couple weeks ago, there's a lot of people that are actually very deeply into storing a lot of data that's being passed currently encrypted data on the internet for it to be broken in 10, 15, whatever, however many years down the road. So I think whenever that happens, that'll be a havoc unleashed. But I think in the interim, I just don't think it's worth the cost for quantum computing, and especially as I don't know, Scott talked about it in depth that like AI systems are making up for a greater and greater increase than Moore's law had at any point in its history in terms of performance. So yeah, I think AI is definitely the way, but also in a similar sense, it did take a while for us to get to the stage where neural networks were actually useful in terms of the technology.
Yep.
So who knows? Maybe I also remember when I was taking a course back in 2018, we had lectures about how it's super hard to generate an image of a cat from a neural network, and now
Right.
5 years later, we have insanely great pictures coming out of Stable Diffusion and everything. And so, like, in such a short period of time, many things can change, right? So,
Yeah.
those.
So one thing that I think about the course is we can be very proud at how quantum focused it is, and eventually that will be useful. And we'll talk about all the years that went by when we talked about quantum, couldn't really fit it into practical things. And all of a sudden, I think it will become practical at some point.
Right. And yeah, I think that's a great point about how fast this industry is growing. And I'd like to quote David Silver from research scientist at DeepMind, actually a postdoc from University of Alberta. He says, as humans, we are very bad at predicting the impossible. So, right, like AlphaGo was like way ahead of schedule. And maybe like that will be with quantum too, right? There's a lot of action in academia regarding that. So I think that would be cool. And if we can solve these problems in terms of like encryption, which are, we can think of problems that are really hard to solve in polynomial time. If we can solve that, in polynomial time, well, it will just map to all these other problems, and now
Right.
we can solve them efficiently.
So what I would propose future classes do, we have so many videos now going back so many years, like take the videos that we have on systemic racism and its potential solution by, computing, and sort of analyze that and see even if you can have champions, that you're for this person, you're not for that person. One of the things that embarrasses me is the way I seem to be rude and stepping all over the other people and stuff like that. So I think it would be kind of fun to make use of those previous videos and to see if they are still describing impossible things or whether the world has changed now and what was impossible then is now possible. Okay, Zayed, it's your turn. Yeah.
Alrighty, let me just get all my things sorted here. Okay, presenter. Yep. Okay, can everyone see my screen?
Well, it says you've started screen sharing, but we're not seeing
Oh,
the
weird.
actual result yet.
That's so strange.
So,
Okay, it says your screen sharing is paused, but I'm pressing resume share and it's like not doing it. Okay, I'm just gonna stop sharing and try again.
maybe if you're like trying to share some huge thing, you should just.
Oh no, here we
That
go.
looks good. Yeah.
Nice, perfect.
Cool.
Yes, okay, great. So I chose to research a little bit about ethics because I think ethics are very cool. And I don't have a lot of technical background when it comes to ethics, but I've always found like philosophy to be very interesting. And my entire degree has been more or less like under the microscope. And so any opportunity I get to talk about things that are a little bit more macro scale and introspective and make you reflect a little bit deeper, I've always wanted to hop on those opportunities. So yeah, one of the topics of ethics that I chose to talk about was conscientious objection. So how that all plays into ethics and medicine, why it all plays into medicine, and then the underlying ethics of all of it. So there's two ways you can think about conscientious objections, and the first being you accept them, and the second being you reject them. So I am pro conscientious objection, but under certain circumstances. So I'm going to go through what all of that looks like, and yeah, hopefully I can convince you to be in the same boat. But I'm going to start it off with like a little YouTube video that I think is very good at laying the land a bit better than I can, because as I say, I don't come from an ethical background. So hopefully it plays well, and yeah, we'll just see. It should set the stage. Let's hopefully you guys can hear it. Can you hear it?
No, we're not hearing anything.
Uh-oh.
So I
Okay.
think you need to share audio.
Mm,
Yeah, you should be able to
Okay.
find the settings to share audio.
Audio settings.
So maybe in the share screen window, there's stuff about sharing
Perhaps.
audio.
Okay, actually, I might disconnect my AirPods temporarily. That might help. Let's see. Okay. Let's try again.
The contents of freedom of religion
Yeah.
or belief.
There we go.
Subjection. Freedom of thought and conscience are protected by Article 18 of the Covenant on Civil and Political Rights, alongside religion and belief. So the right to conscientious objection is part of freedom of religion or belief. Conscientious objection means refusing to do something you are required to do, because doing it would violate your conscience or religious belief. Examples of things people claim a right to refuse to do include compulsory military service, taking oaths, receiving blood transfusions, or participating in some medical procedures. The only specific form of conscientious objection mentioned in UN documents is the right to refuse military service. And it's not mentioned either in legally binding UN conventions or in the Universal Declaration of Human Rights. Instead, it's mentioned in General Comment 22 of the United Nations Human Rights Committee. This is a document written by UN human rights experts, which explains how states should interpret Article 18 of the International Covenant on Civil and Political Rights. This committee concludes that Article 18 supports a right to conscientious objection to military service if being required to kill seriously conflicts with your freedom of conscience and the right to manifest your religion or belief. Many countries recognize this right and offer alternative national service systems and exemptions. But there are still a number of states that imprison those who refuse to do military service because of their religious or pacifist beliefs. Jehovah's Witnesses are the group most heavily affected by this. For example, in South Korea, 389 Jehovah's Witnesses were serving prison sentences for conscientious objection in December 2016. According to UN human rights bodies, alternative, non-military service arrangements should be accessible to all conscientious objectors without discrimination. And everyone affected by military service should have access to information about the right to conscientious objection and how to claim it.
Okay, I'm gonna end it there
Yep.
because the video tends to talk a little bit more about objection to join the army, but in the context of medicine, we discussed it a little bit in Dr. Van Manen's lectures, but conscientious objection in medicine is when you as the patient are asking me to provide some form of care that violates or goes against my own morals or moral standing. So one of the most common ones that's talked about the most is the case of abortion. So for example, if my religious beliefs as the physician tell me that abortion is prohibited and you ask me to perform an abortion for you, it might be permissible for me to object to provide that care on the grounds that it violates my morals. However, there are several conditions that would allow that objection to be valid, which I'll go over in just a couple of minutes. But yeah, in the context of medicine, it is me as the physician objecting to provide some sort of care or treatment on the grounds that it violates my own morals or beliefs. So we'll keep going along here. So yeah, back to Dr. Van Manen's lectures, he underlines 4 main tenets of medical ethics that, being able to uphold all 4 of these makes what's called a good doctor. So the first being the virtue of beneficence, which are norms pertaining to relieving harm or providing benefit. So as the physician, I have a duty to provide you, the patient, with some form of benefit when you come to me. Secondly, there is the tenet of non-maleficence, which is a norm of avoiding the causation of harm. So I must do my best to ensure that you are not in a worse position than you were prior to seeing me or requesting care. Number 3 is autonomy. So a norm of respecting and supporting autonomous decisions. This is a little bit deeper. So this also means that you provide all of the relevant information for your patient to make, the right decision for themselves. You're not overbearing with your own beliefs. And so again, it gets a little bit trickier when we consider conscientious objections, but again, I'll get into that in a little bit. And then there's justice. which is a cluster of norms for fairly distributing the benefits, risks, and costs associated with care and treatment. So when we talk about conscientious objection, a good physician is able to make an objection because it violates his or her moral standing. So when it comes to beneficence, firstly, it might be hard for one to support conscientious objection because on the surface, it seems like I'm not really doing good by my patient by objecting to provide them with some form of care. And so if we move on to the next slide, there's a few. Oh no, I don't know what happened. Yikes. Sorry about that. All right. Can you see the screen again? No.
So we're not seeing.
So we
Sure.
technology. Okay. There we go.
Yep.
All right. So in the case of conscientious objections, there are 6 things that need to be upheld in order for them to be validated. So let's say, again, we return to the example of a patient requesting an abortion. If I conscientiously object to providing that care, I must be able to refer them to somebody else that I know will be able to provide them with safe and effective care in a timely manner. I must continue to respect the patient because at the end of the day, it goes back to like the famous example where if you have a serial killer that ends up on your operating table, you still have to operate on them because they are a human being that needs your help. And so same thing here. I might not believe in abortions or I might not support them, but the patient needs it so that, they could either survive or increase their, well-being or health. And so I must continue to respect them in that way. The person that I'm referring them to must still provide them with non-discriminatory treatment. So same deal. It's just, I'm a human who needs care. You are a physician who provides care. And that's sort of it. There's no misconceptions. There's no perceptions of the person or, the kind of morals that they have or who they are as a person. It's just human being needs care. I provide care. The care that will be provided is not unduly burdensome. And then privacy and confidentiality of the patient is upheld as well. So if we can maintain all 6 of these criterion, then generally speaking, conscientious objections should in essence be valid and supported in the world of medical ethics. And that is sort of what I argue. And then when we return to Dr. Van Menen's lectures, there was something that he described as the proto-ethical question, which is, what is going on to which I must now respond? So this is basically the question that every physician asks themselves at any given moment of any given day. So if you think about when you visit the doctor's office or your family doctor, your nurse takes you into the little room and you wait inside the room for however long, your doctor is probably standing outside of your room for about 5-10 minutes, going over your file, thinking about, who you are as the patient, what you might need. And in that moment, they're asking themselves, what is going on to which I must now respond? And then they enter the room and they ask you, specific questions about why you're there and what you need. But yeah, when we return to conscientious objections, again, you have a patient presenting to you requiring some form of care or treatment. And you must now weigh several other things, which are how you can provide the care, how you can provide the treatment, and also how it aligns with or doesn't align with your own moral status or moral standing. And so if you come to a position where you don't feel comfortable or you don't feel as though the care that you will provide, can be validated by your own morals, then now you have an additional step to take in your response to what is going on, which is who you're going to refer them to, how you're going to refer them, and how you can ensure that the patient has the same amount of access to healthcare as anybody else that you might operate on that same day. And then additionally, when it comes to the justice piece, you want to make sure that your patient doesn't lose trust in the healthcare system as well. And so if all of a sudden everybody just objects to all treatment, then what is the point of having healthcare, and what is the point of patients having trust in their doctors? So this is an additional consideration that a physician might need to make if they are making a conscientious objection. How can we uphold the justice piece? This is a very important part of it. So I'm going to return to the proto-ethical question later, but just wanted to like plant that seed again and remind us of it so that we can think a little bit deeper about it. And then throughout my research, I tried to be a little bit nuanced and consider things that, you know, there might not be any research on right now, which is how AI plays into all of this about medical ethics, particularly with conscientious objections. So as of right now, the main issues, not all of them, but the main issues that arise and the main discussions that arise about conscientious objections revolve around care and treatment that violates a doctor's morals or standards or religious beliefs. And then now, with AI growing in its prevalence in medicine, there's AI that's used now for medical diagnostics and treatment planning. And so some physicians who are not familiar or used to the use of AI assisted tools might feel hesitant to rely on them or to use them or to say, yeah, AI decided that this is the treatment plan, so I'm going to go with it. So now you could start to question, or you can start to consider how I, as a physician, might make a conscientious objection to using an AI assisted diagnostic tool, because there was no human involvement in that particular diagnostic or that particular treatment plan. And so again, there's another idea about ethics, which is sentience. So sentience is a thing's ability to feel or experience, particularly pain. And so if you think about AI, AI has no idea how to feel those sorts of emotions or feel those feelings. And so how can it articulate what's best for a patient when it itself has never been a patient, nor will it technically understand what a patient is going through, which is why some physicians have that hesitation. But I argue, and several others argue as well, which I mentioned in my paper, that AI-assisted treatment planning and or diagnostics with human input can be valid. And so when we think about, let's say, diagnosing some kind of tumor that would take a few CT scans and a few deliberations with doctors to finally deduce, yes, this is definitely a tumor. Yes, this is something that needs to be treated. If AI streamlines that process and then it's overseen by one or two or like a panel of doctors, then I feel like there's the function for AI. This is where we can start to rely on it. And this is where the future of medicine can go in an ethically sound way. And then this idea of conscientious objection becomes a little bit less important or less significant, because it's a lot harder then for physicians to look at that kind of case and be like, yeah, I don't really trust it because there's no human input. So I argue that human input is required for these sorts of issues to just diminish. So while at the beginning I mentioned that conscientious objections should be valid for a number of reasons, I also want to think about a world where we don't even have to have these debates or have these arguments. And so when we think about AI's place in all of this and how it comes into play, I think that working collaboratively is always like a good way to go about things. And so there was also the piece about reflection that Dr. Van Manen mentioned, and how we can't just make an ethical judgment today and then continue on tomorrow and make a different ethical judgment and then, you know, continue living our lives. There's always room for reassessment and reflection about why we came to the decisions that we did, how it impacts us as the doctor, how it impacts the patient's family, the patient's life. And so this reflection piece and the reflective equilibrium that was mentioned, this is how medical ethics continues to progress. And so this is where we can start to have conversations about how AI might shift our focus a little bit, shift our thinking, shift the whole paradigm of medical ethics to a new nuanced space that we have yet to conquer. Yeah, so it was just a cool little thing that I came across and wanted to explore a bit and let you in on as well. And hopefully it gets you thinking as well about how AI plays into ethics as well. But Yeah, that is essentially my overarching take on conscientious objections, and I will happily take some questions if you have them.
So, the last part of that about, the absence of human input, another way to look at that is that is a prejudice against machines. When machines are as capable or more capable than we are, if you reject them just because they are machines rather than the fact that they can't do something, that is a prejudice or a bias. Have you thought about it that way?
Yeah, definitely. Which is why I think that working cohesively with machines is the best practice, I think, because again, over time, artificial intelligence will continue to grow and develop and become smarter and potentially be capable of understanding the human condition. And so, in that growth mindset, we have to treat it like it's a baby being born. So, we have to be able to nurture it and not hold that prejudice instead of alienating it. Because as soon as we start to bring up these ideas of the us versus them, then the cohesiveness goes out the window. And so again, then you get to have larger debates and you get to have more tension, and then pushing the needle becomes way harder. And then
Right.
ultimately, when we think about this as physicians and as we talk about medical ethics, care for the patient is the ultimate virtue we have to uphold. And if the introduction of machines or AI makes that process more seamless, faster, or more streamlined, it's almost a no-brainer to, adopt those sorts of things. Does it take a little bit of extra work and a little bit extra consideration and reflection on our part as the humans? Absolutely. But to prejudice against the machines, I don't think is the right way to go.
Okay, Scott?
Yes, go ahead.
Yeah, cool. Yeah, cool presentation. I'm pretty happy that you kind of picked this topic because the Dr. Van Manen lectures were really good. Yeah, so my question is, I guess like when I think about theory, I mean, ethics, when we think of it kind of in an academic setting, it's very kind of theoretical. And obviously there's like a big like gap between practical practical practices in medicine and kind of like the theoretical ethics behind the decisions we make. And in this case, conscientious objection. And so my question is like regarding um the six the criterions for having it work, like that's kind of like an optimal setting, right? But that's not always going to be possible, right? I think Dr. Van Manen talks about what if like you're in like a super remote place and like there is just no other doctor to help you abort a baby, right? So if those six criteria need to be checked off for this to work, and that's just not the case practically in real life. So like what's kind of your like answer or
Yeah, that's a great question. I spent a little bit of time considering this, even just for myself. Like if I was to be a physician and this is something that, I had to deal with, what would it kind of look like? And so again, it kind of comes back to how you can support conscientious objections moving forward. And so I think my personal opinion is that if you are ever in a scenario where you feel as though you should object to something, but those criterion can't be upheld, like the next available doctor that can provide you with an abortion is in Saskatoon, and you're not going to make it there in time, then I feel that because I signed up for this job, for this kind of service to humanity, I have an obligation to provide you with the care, even if it goes against my morals, just once, because this occurrence is probably going to be very rare, where
you make a conscientious objection to something, and then ultimately you're the only one that can provide it. I think that's not going to happen very often, but on the rare occasion that it does, I think it's one of those scenarios where you might have to just kind of cut your losses a little bit and remember that your objection isn't adversely affecting somebody else's life, potentially for the rest of their life. And so ensuring that that doesn't happen could be supported more morally than simply objecting because it invalidates my beliefs. So if I believe in pro-life and I think aborting is so bad and nobody should ever do it, but the health and well-being of my patient might end up being far more negatively affected than me simply going ahead with an abortion, I have a duty and an obligation to provide them with the care that they need. So that's sort of where I stand when it comes to scenarios where you can't uphold all 6 of those criteria.
There's kind of a practical side here, I think. In career choices, you shouldn't pick a career where like 50 or 60% of all your instances of what you're doing in that career will require you to register a conscientious objection, right?
Yeah.
That means you've painted yourself into a corner. And I think
Mhm.
a lot of high status, unhappy people have somehow done that. And it's kind of interesting to study, and I hope none of you do that you make choices at critical points in your life that have you end up in a place where you now feel you're in this rigid box, behaving in a way during your work life that you don't want to behave, but you can't do anything about it. Well, that's not just the thing that society does. You have made choices to get in that situation. So this would be one of them. If you morally object to most of the work that you're doing, that means you made the wrong choices in deciding what work to do, right?
And then additionally, if I could like add on to that, I also feel that if we were to be in a situation or in a world where conscientious objections were prohibited, this might also limit the pool of people who want to become doctors, because then it'll become almost one way of thinking, and there's going to be less room for diversity, less room for a diverse moral principle pool, and it might end up ruining healthcare. So yes, you must consider the job that you're going into, but at the same time, we don't want to make it too restrictive in that we get one type of person providing care to people, because everybody that requests care come from different walks of life. And so if they only interact with one type of person, one kind of robot, then, that might be negative as well. So that's another thing in support of conscientious objection, is that it also promotes diversity in jobs and in morals and in conversations and in discussions. So
so speaking of that, medicine is very broad, and I think if you think of all the unique career paths, probably the ones already followed represent maybe only a quarter of those that are possible. So you can carve out your own path that maximally matches the kind of things you want to do during your work life and what that path requires. And maybe you'll end up doing something that's not quite the same as what anybody's ever done before, but that can be exciting. So I just wanted to point that out as a part of this maximizing diversity. So we have 10 more minutes. Any other questions?
It's not my share, actually.
I'm pleased with the turnout today.
I have a follow-up on that. I think so just like an idea that just like came to my head is basically like, I think it's like, I totally agree with you when we talk about conscientious objection really like promotes people going into the field to really, stick with their beliefs and not feel limited, and like that their occupation would limit them. And that's actually a great point that I like didn't even think of. And so I know of this couple that has a kid with some illness, and like they had this one doctor that just wasn't meshing well with them, so they decided to go to see another one, and that was like a total game changer, right? And so I feel like a big theme in medicine is like, or finding like a doctor is like finding a doctor that really fits your circumstance and fits your need. And that's like to have that's very like a very privileged thing to have, and I recognize that. So do you think like just like really having like a big pool of diverse physicians and or just people in the medical field period can kind of like remedy a lot of the issues that people have with conscientious objection? And if so, do you think it'll get to a point where like if you have too much, it will start having negative effects? Yeah, kind of like an out there question. I'm just kind of wondering what you think.
That's a good question. Yeah. I think one thing to remember is that in medicine, there's a lot of collaboration, particularly as you start to specialize a little bit more. So let's say when you're preparing for surgery, it's not like you're the one surgeon who deals with it. You have, your assistants, and that's kind of it. There's plans of action, there's protocols, there's standard procedures that might need to be edited a little bit on a, case to case, patient to patient basis. And so I think having a larger, like a more diverse panel of people discussing and considering the factors will end up, hopefully, like 9 times out of 10, providing the patient with heightened care than had it been one style of person. Will that ever get to a point where it's too much? I mean, yeah, if you start involving just by sheer number, like then too many people, period, like regardless of their views, then it might get a little bit too complex and too convoluted, in which case, again, you're no longer maintaining the timely manner piece. And so, again, we have to think effectively and meaningfully, but also in a fast fashion to ensure that, patients aren't under the circumstance of harm for too long or longer than they need to be. But I think more diversity should always be like a good rule of thumb. I think if you have to choose between the two, always go for more than less. But thinking about a world where there's too much, that's very hard to conceptualize, I have to be honest.
So what will happen is that medicine will change to a point where human enhancement is the main focus. And that will naturally change the kind of people going into it as a profession. So people whose vibes are more about, equity and providing choice and freedom, but not adversely impacting on other people's rights and that sort of thing. Like, you can imagine that so-called morphologic freedom, having the right to look however you want to look, that sort of thing, might be fine to a certain extent, except with maybe the issue of size and door frames and stuff. Like if you create a body or, enclosure for your digital self that doesn't fit through any of the entrances to things, that's obviously going to be a big problem for everybody, right? So yeah, there has to be some societal limits on what, and you can imagine that if you create an outside appearance so that it's not clear what you're thinking, what you're feeling, then human cooperation is going to be much harder, right? If like everybody else, you can look at the person and see if they're happy or not, and so on. But you've created some external thing about yourself that does not allow you to show how you're feeling inside, then the ability to cooperate with you seems to me is less. And probably society would also lessen that. It's just like in certain countries, you know, we think Halloween masks are just fine, but in certain countries, you actually can't do that. You can't wear masks, so people can't tell who you are.
Yeah, yeah.
All right, we've got 3 minutes. Is somebody
Shara Hill, yeah.
yes, Shara Hill.
Yeah, just first of all, great job, both Scott and Zayed. Very interesting and in-depth presentations on two very separate topics, which is always very interesting to see. In terms of this last discussion, I just wanted to say, sort of based on what we've been discussing now, is that it's interesting to consider that medicine itself is different depending on where you go in the world. Sort of the approach to medicine is very different. So how do you think that changes the ethics of medicine and the concept of, conscientious objection?
It's a great question. I think predominantly from the reading that I've done, conscientious objection seems to be a topic of the Western world more than it is anywhere else. Because at least we like to think that we are very diverse in the West. And so by extension, we have to make all of these exceptions for so many different people because they come from so many different walks of life. But I think because of that as well, we're also able to consider many different perspectives here and not treat them with as much prejudice as you might get somewhere else. So for example, I'm from Egypt. And so if you were to request an abortion in Egypt, it would be very, very hard for you to make that happen because Egypt and for a lot of other countries in the Middle East, a lot of them follow, Islamic rule, which prohibits abortion. And so the place for conscientious objection, you might see conscientious objection occurring a lot more in those areas, but at the same time, it might not be as valid still because the ability to provide the patient with care might still be diminished as a result. And that's just one example. The way medicine works in other countries as well, there's, ancient Chinese medicines, there's, European ways of doing things, there's specific Mediterranean ways of doing things. And so it's hard for me to say how conscientious objection might play into so many different, cultures, but I think it seems to have its place a lot more in the Western world or in any society that is willing to make accommodations and accept others for who they are and what they believe in. And so it all comes back down to that idea that we all have a freedom of thought and freedom of religion, and anywhere where that doesn't exist, conscientious objections might become a little bit more of a hot topic. So that's sort of like where I think, yeah, I hope that answers your question a little bit.
So I have a practical question. Thinking back in the history of the course, Vanessa Rogers, she's one of the exemplar presentations that I've given you guys the link to of her talk from, I don't know, about 10 years ago or something. But she, like you, in the actual talk, had a number of sort of interruptions and stuff like that. And we went in and edited all that out. So the final product is so beautifully smooth, but it's not how it actually occurred. Do you have any video editing skills? In other words, if I sent you your own video, are you able to do any editing, or should I get that done elsewhere? Because I think we ought to do it. It just sort of needs that.
My video editing skills are not strong.
Okay. No, that's fine.
I could like give it a whirl.
No. I think we might wreck the whole thing. No, I'll do it. I just wondered whether you were like you know, you do video editing as a hobby and.
Oh, I apologize. I must disappoint you.
Yeah, okay, good. Well, this is a great first presentation day, and we look forward to next Tuesday. So you guys have a great weekend, and yeah, also your papers are due today. Yeah, so.
Well, I just had a question. Did
Yeah.
you want us to email you our
Yes,
paper
yes.
and our presentation?
Yeah, that would be good. Yeah,
Okay.
I mean, it sort of depends upon the circumstance. If there's something
Mhm.
extremely mysterious about your presentation, or you know, a lot of graphics where I have no idea where they came from and who owns them and stuff. Yeah, but I don't have to have everybody's presentation, but I wouldn't mind receiving it. Yeah, yeah. So that would.
Okay, sounds great.
Yeah, yeah. Okay.
All right. Thank you,
Great.
Dr.
Okay, we'll see you on Tuesday. Yeah, bye-bye.